All right, so in this video, I want to show you how to combine nearly everything you learn at the beginning of a high school physics course to create any kind of graph for any kind of motion that you want. What we're going to do, we're going to start over here at the left. The first thing you learn about in physics class is mass. Everything has mass. Mass is usually kept constant, so we're only going to enter it once here in this cell A2. So let's suppose we're working something with half a kilogram. The next thing we need is time. Right, time is the independent variable. It's a thing that marches forward no matter what. And we've got time moving forward at a steady clip of 0.1 seconds each frame. Now you could change that if you want to. In fact, we'll do that a little bit later, I think, to change this this value to be a little bit smaller so it moves a little bit more smoothly. But this time here, this is just the time on the stopwatch moving forward. Then here we've got the amount of force you're applying to your half a kilogram object. We're going to start out with constant force here. All right, so you're just going to start out with a force of 1 Newton. We will change that in a little bit. Actually, let's make this equal to all the ones previously. When I change it, I only have to change it once. There we go. Okay. I'll come back to how I did that in just a second. Here we've got the acceleration. So the way we're calculating the acceleration is as the force divided by the mass, right? That's Newton's second law. When something accelerates, that acceleration is equal to the net force applied to it divided by its mass. You notice I put these little dollar signs in front of the A and 2. That's because when I go down here, I want this spreadsheet to automatically update this C value. I want to go from C10 to C11 to C12, C13, etc. But I want it to leave A2 locked in place because I've only entered the mass once. So the dollar sign there is just an anchor to say that you shouldn't change that cell value. Then in column E, we've got how much the velocity changed in the previous cell. So to get that, we're taking the acceleration times the change in time. That's how you get a change in velocity. It's just the acceleration times the change in time here. Then over here, we've got the new velocity. The way we're updating the velocity, we're taking the old value plus how much the value changed by. Same thing in the next cell. The old value plus how much the value changed by. Same thing in the next cell. Old value plus how much the new value changed by. Then we need to do a similar trick here for the position. So I need to calculate how much the distance changed by, how much the position changed by. So I'm taking the velocity times the change in time. Next cell is the same thing. It's the velocity times the change in time, etc. And then here, to get the new position, I just add the previous position plus the change. It's really the same trick over and over again, right? You're just taking the formula for velocity and rearranging it, taking the formula for acceleration and rearranging it into a form that the computer can use. And once you have these entered, you never have to enter them again. You just change the stuff that's up here at the top. So let's see what we've got here. We've got a ball, block, whatever you want it to be, starting out moving in the negative direction at 7 meters per second. And lo and behold, that's what we've got here. The thing is moving downward pretty steeply, right? A slope of -7. We're applying a force in the positive direction. A force in the positive direction is going to take away velocity in the negative direction. That's why our velocity here decreases. You can see that over here in the graph, because the slope is decreasing. Actually, that's kind of difficult to see because we can't see the whole thing. So let's double click on here to get this minimum. Let's make that a negative, maybe we need a -10 or something. There we go. Probably end up changing that later anyway. So here you can see that the slope decreases, right? This part here is not as steep as this part over here on the left. I can make that even more dramatic if I make the force stronger. Let's go from a force of 1 to a force of 2. You can see here how the parabola bent a little bit. So the force tells you how much the parabola bends by, right? Because you're trying to deflect the thing away from its path. You're literally trying to bend this trajectory, and that requires force. Let's up this to a 3 here. We'll see an interesting feature occur. You notice that at some point we end up turning around because here we've got a negative slope. Here we've got a positive slope. So somewhere in the middle we got to have a 0 slope. Somewhere in the middle we've got to turn around. We can even tell that from our numbers here, right? Our velocity is increasing. It's going from more negative to less negative. And then in between these two cells here, we go from -0.4 to 0.2. So in between these two times, 1.2 and 1.3, we got to pass through 0 velocity. Now it's kind of hard to see where that minimum is right? Because I can't quite tell where that 0 is, and that's why you might want to change these time values. So instead of going forward 0.1 seconds at a time, we might go forward 0.01 seconds at a time, right? So what I can do, I can say that this next one is equal to this thing plus 0.01. You can do the same thing down here, equals this plus 0.01. Now that's going to get tiresome to type after a while. So what I'm going to do is grab this thing called the fill handle, click and drag this down, and notice it fills in that formula as I go down here, right? So each one of these time cells is just the previous one plus 0.01. Now actually, let's go up here and let's freeze this top row just so that we can see it. There we go. Now you notice I don't go as far forward in time as I did before, because last time I went to 2 seconds, now I'm at 0.28, because if you make the time step smaller, if you make this difference in time smaller, you're not going to get as far in as many steps. You have to take more steps. So here's what we're going to do. We're going to grab everything on this spreadsheet, right, from time all the way down to position, because these are all formulas that are just going to get copied down. We're going to grab the fill handle and we're going to move this down until we get to 2 seconds. Okay, so at 82, I was at here, so I should need to go to about 200, it looks like. And there we go. So I've dragged down 209 cells. This thing has been copied 208 times. And you notice each time it preserves the formula, right? This position is the old position plus the change. The distance traveled is the velocity times the change in time, right? It's the same formula, just copied down and translated down. Let's see, we'll need to make an adjustment to our graph here because this thing is only taking the first so many data points. So let's see, it's only going down to B21. So let's have it go down to B200 where we dragged it down. I guess it was 201 I dragged it down to. We'll click OK. And then I need to do the same thing with the Y data, so I'll make this 201. There we go. And what you notice, I end up with more data. I end up going farther along to time equals 2 seconds. But what you notice is this is a lot smoother. Before we had block, 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 block for the data points. Here the data points are so close together that they're overlapping with each other. This is a much smoother curve. And that's the trick to modeling physics with a computer. The smaller you make this step forward in time, the more accurate your results are going to be. Now the downside is it takes way more calculations, right? So you've got to have way more rows involved, all the way down to, 209. I guess I should have made that 209. Oh well. But it's more accurate, it just takes more work, right? I mean, there's always going to be a trade-off between accuracy and the amount of work that the computer has to do. But here's the thing, it's the computer doing the work, not you, right? You just enter the formula once and copy it down, and this graph will automatically adjust. So let's see what we can play around with here. Let's see what happens if we make our initial velocity 0. Let's start with a 0 velocity. I will need to adjust these. Let's go ahead and make these their automatic values. There we go. Notice what happens when I set the velocity equal to 0. I start out flat here, right? I start out with a parabola that's flat here, and then I end up increasing it, right? I increase my slope, so not only is the thing going up, it's going up at a faster rate. That's that change in velocity that we have. What happens if I start with a positive velocity? Well, then I start off with a little bit of a slope, and my slope continues to get steeper and steeper. Now watch this. This is the fun part. Let's turn our force in the negative direction. Let's make this a -3. You notice we get the opposite of the effect that we have. And so we flip the sign of both the velocity and the force, and now we have a parabola that's opening downward. So this thing is now accelerating in the negative direction as opposed to accelerating in the positive direction.